100 years ago, we had very crude technology. There was very little we could do to fix problems. We didn't understand the origin of many neurological disorders. Now we have a better understanding of these neurological disorders, though it's not everything is solved, but we have some we understand better than others. And right now, but we are working on ways of, fixing these in the lab. And there's also people are working on techniques to do sort of non-invasive stimulation, either with ultrasound or magnetic fields into the brain, as sort of non-invasive ways of perhaps altering brain activity in a positive way and treating some disorders. I'm Patrick Drew. I'm a professor of engineering, science, and mechanics at Penn State. This is Brain Awareness Week, and I'm here to talk to you about how technology has improved our understanding of the brain. So the brain is an incredibly complicated organ. It has hundreds of billions of neurons in it that send electrical and chemical signals to each other, and understanding this requires the development of new technologies. Mental and neurological disorders are caused by problems in the brain. And in order to fix these disorders, we need to understand how the brain works normally. And we want to understand what's changed in these disorders. So by using technology and ways to image, record, or stimulate neurons, we can study how the brain works normally and what goes wrong using model systems like Drosophila, fruit flies, or mice, and also in human patients, and with the eventual goal of moving this understanding that we develop in the lab into treatments for people with real problems. If we know what's going wrong, we can develop interventions to change the neural activity or other deficits that might be present. So one example of a treatment is deep brain stimulation for Parkinson's. So this is where people with Parkinson's disease are implanted with electrodes, and they have electrical stimulation in a specific region of their brain that helps recover normal function. As a neuroscientist who studies how the brain works, we still have a lot of basic understanding that we need to do and things we need to figure out. And this is a very important groundwork for future treatments. And so we hope that much of what we're doing now will lay the groundwork for treatments for our children and our grandchildren. Nice. A summer job making electrodes when I was an undergrad. You sit in this room.
In them?
That would be great.
Cool. To show first-person shots of science instead of just